Okay, so this recording will be for the class Tuesday, May 16. So for today you have a homework due. Being the first time, and the first time we're going to be recording the class, maybe let me be the one doing most of the work over here. So, all right. So let's see if this works. Let me know if you have any issue on the screen to read my handwriting, or if I run, out of space and I need to move to a different page. So hopefully these markers here would work that I found. All right, so I don't see that clear. Oh, because on the other side. You can see the other side of the paper. So I probably need to switch paper. I was trying to save some paper to working on the back on some other paper, but that might not work. All right, so let's say homework 1. All right, and the problem you have to solve, you over here, a block of mass capital M, which is connected to a spring of stiffness K, and this one is connected, and then there's a bar connected to the block. So this corner here, we call it B. Let's say this one will be C. Then the angle between the bar, we call it theta, and the mass, and this bar is going to have a mass letter M and length L. Okay, and this, let's say, is rolling on a surface. All right? So I'm just going to put it here for simplification, but let's say our current system, it's going to be here X, and this will be the Y. So the question here was to determine the equations of motion for the block and the bar. Okay, so first thing we need to do is to solve this problem using Newton's equations. So Newton's equations. So let's see, what is the general approach to write down equations of motion using Newton's equations? We said last time, Newton's equation is a vector equation, so we need to do free body diagram. So what are the two rigid bodies, the two objects we have in this problem? We have a block over here of mass capital M and a bar of mass little m. Okay? What type of motion is the bar having? What type of motion is the block having?
Pure translation.
Translation, and the bar, just translation. So let's first do a free body diagram for the block. So let's say block over here, we're first going to study the block. Red doesn't work too good. Orange doesn't work too good either. So block. So basically you disconnect the block. So we go here. So if we do here the flipper diagram. So we have what? We have a force. So let's say we assume that we displace this object a little bit to the right. So what is the force of the spring going to do?
Pull left kx.
Pull to the left. Then what will be the other forces over here? Due to the, so we have the weight. Oops, it's capital M, G, no letter M.
The reaction forces from the bar.
Correct, the reaction forces from the bar. So we have dy dx, and we should also have the normal force. Okay? So now on this side, what type of motion is this block having? MA, which should be the same as MX. Double dot. Alright, because this is X, no? So when this is moving, this is moving a distance X, the center of the block is moving also a distance X. Alright? So again, this is, so what type of motion is this block having is translation. So what is the equation describing the translation?
Sum of the forces is equal to mass times acceleration.
Summation of force is equal to the mass times the acceleration. Alright? So over here, we write down then the summation of forces. Let's do X direction. So what would be that equation over here? We have minus kx, this one here,
Plus bx.
plus bx will be equal to mx double dot. Okay, over here, if you want, you can go and write the equation on the y direction, but I don't think it's needed because in what direction is this object having the motion?
Only x.
Only on the x, so the x should be enough. So let's say, let's call this equation here equation 1. Alright, so let me switch page. I have some space at the bottom, but I'm going to do the other one now. And you don't copy, or do you need more time? Alright, so page 1. So let's go to page 2 over here. So now we're going to do the same thing for the bar. For the bar. Going back to this figure very quick. I don't know if you noticed, but that I make here two figure diagrams. The summation of forces is this one, and then the one for MA is this side over here. So you have one for the external forces, one for what is called the inertia effects or the effects due to the motion. Okay, so we go to the bar, and now basically we do the same thing over here. We have the bars over here. So what would be the forces acting on that bar?
The reaction forces at the point.
The reaction forces, but then it should be on the opposite direction, no? Action, reaction.
Yes.
So meaning that, oops, sorry for that. At point P over here, dy should be going down. Px should be going left. Okay? And what else do we have? the force, the gravitational force mg. Okay, and now what are we going to have in this figure on the right hand side? What type of motion is the bar having?
General planar motion?
So general planar motion, so maybe put it over here, which means what?
Both translation and rotation?
Both translation and rotation. Okay? So that means, so if we look at the translation, that would be what? Would be, you will have here, you will need an M, let's say ACX over here for coordinate X, and MACY. This would take care of the translational motion. And now what do I need to add for the rotation? Some I alpha, no? Okay, so since the equation has translation and rotation, that means we need to apply the equation. So first, let's say on the x direction, the summation of forces equal to MA we should give you what? Minus dx over here. Do we have any other force on the x?
Nope.
Equal to MACX. So let's say that would be our equation 2. We need to do the same thing on the y direction. Summation of forces equals to A, which will give us what over here?
Minus by minus mg equals may or acy.
Equal MAC so on. I mean, I think I told you that this is a classic problem. So did you go and look for it in some textbooks?
We looked for it and we couldn't find it.
So, okay. So this would be 3. All right, so that takes care of the translation. Now, what is the equation that will take care of the rotation?
Sum of the moments is equal to I alpha.
Summation of the moments equals to alpha. So what is important that you mention when you take moments?
What point they're around?
Correct, so what would be that point?
C.
C, C. So that's very important because otherwise I will always pick the wrong location. So here I might have to add something on the figure. So let me add here the angle theta. So what would be the equation over here? What is, let's start by, let's say bx. Is bx here in a positive or negative moment?
Positive.
So it would be bx
Times L over 2 times the cosine of theta.
L over 2 times, so bx will be the cosine, cosine of theta. What about by? Is it positive or negative?
Also positive.
Also positive, so plus by
Times L over 2 times the sine of theta.
sine of theta. Anything else?
No.
It look like, and that would be equal to IC alpha. Okay, here I didn't put it, but if you want really alpha is equal to what?
Theta double dot.
Theta double dot, no? And this should be equation 4. So basically, if you took the dynamics class with me, this is exactly the same procedure that I teach in that class. So first thing you do is free-body diagrams. 2, you write down the Newton's equations. 3, what do you need to do? You need to find out, okay, we have 4 equations. How many unknowns do we have that you can look at this problem here? Looks like we have, what, for equation 1, we have dx, so known. We have equation 3, well, we also have acx is unknown, dy, acy. Okay? All right? So that means...
Do you also count theta and alpha?
And theta and alpha will be unknown as well, yeah. So basically, what we need to do now is go to kinematics to find expressions for what? Really what we need to find is what will be with acx and acy, no? Mm-hmm. In function of x and theta. In the first one, we did not have to do that, okay? Because we found out right away that a over here would be just x double dot, no? Mm-hmm. With the reference frame. But here, what should be this one? Should be x plus, just by guessing, should be x plus or minus some L over 2 sine theta, no? Mm-hmm. If it's moving. So let's see what the kinematics will give us. So let's say we go here now to kinematics. To find the relation for those points. So we have the acceleration of C. This will be a review for dynamics. So we need to write the acceleration of point C. We need to do it with respect to one point. So we can write it with respect to which point? Probably point B, no? Mm-hmm. That would be AB. And what is the acceleration of point B?
X double dot.
Should be x double dot. Perfect. So, but then we write the equation plus alpha over here cross R of C with respect to B minus omega square R of C with respect to B. Okay, so in this problem, we know right away that this will be x double dot. And here's something that they not mentioned in the problem, but this will be what?
Theta dot.
We can do theta dot, but I think we can simplify. Okay, let's do theta dot. Okay. Theta dot. Yeah, why simplify? Okay, so if we write this down to the matrix form, this should equal to what? Equal to x double dot 0 plus, we do here the cross product, I, I try to leave more space, K, let me change the color here. What is the position of C with respect to B? What would be the x?
L over 2 sine theta.
L over 2 sine theta, position of C with respect to B. Okay, and what would be the y?
Negative L over 2 cosine theta.
Minus L over 2 cosine theta and 0. Okay, and this one here would be, sorry for that, should have started with this one, 0, 0. And this should be alpha, but we know that alpha is theta double dot, no? Mm-hmm. Okay, so now, minus, I'm going to put this one, minus theta dot square times L over 2 sine theta minus L over 2 cosine theta. So this would be AC. So from this equation here, we're going to get what? ACX would be equal to what? X double dot plus L over 2 cosine theta double dot
minus theta dot square L over 2
minus theta dot square L over 2 sine theta. To simplify this problem, I could have said that the bar and the block started from rest, meaning that all these terms would be 0. But this will be equation 5, and ACY will be what? So ACY should be equal to L over 2
theta double dot sine theta
sine theta double dot, correct?
minus theta dot plus theta
Plus
dot square
theta dot square
L over 2 cosine.
and over 2 cosine theta. Okay, so basically that is the problem. Now we just need to do some algebra. So let's see if I can put those pages in front of me. All right. So let's see. Okay, so we're going to write here substitute in 5 and 6, I think it's into 2 and 3. Let's see what happens. So what is equation 2? It's here. It's minus dx equal to m ACX will give you what? So let me just do it right away. It will give you that dx is equal to m, and then I just change the sign for ACX here. So what was ACX? We'll have minus x double dot minus L over 2 cosine theta double dot plus theta dot square L over 2 sine theta. Equation I. So what was equation 3? Is minus by minus ng equal to n cy. Then if I go off screen, so this will give you what? by will be equal to minus n g plus ACY. or dy will be equal to minus m and g. What is ACY is L over 2 sine theta dot double dot plus theta dot square L over 2 cosine theta. So next we're going to do substitute the little one, so in Latin one into Greek one. So what did I give us? The expression, what was the equation one? It's minus kx plus bx equal to mx double dot, no?
Yes.
So now only thing we need to replace those with this bx, we get minus kx plus m minus x double dot minus L over 2 cosine theta double dot plus theta dot square L over 2 sine theta. And this should be equal to mx double dot. So if we simplify that expression here, so let's try to combine this one. We should get letter M plus capital M x double dot plus kx. You see I'm moving everything to the right hand side, plus kx plus, let me factor out this L over 2 with the M, so we are done with this one, plus M L over 2. Now I need to be careful here. Of what?
Cosine theta.
Cosine theta. Theta double dot.
Minus theta dot
Yeah.
squared sine theta.
Yeah, thank you. Equals 0. Okay? So what would this be? This will be the equation of motion for what?
For block.
Of the block.
So, Professor, would it be valid in this problem to use the small angle?
Yeah, that's what we're going to do next.
Oh, okay.
Yeah. And actually, it also be valid to say, for example, that the system is initially at rest, which will mean what? That all these terms here, the omega will be 0, no?
Mm-hmm.
So you see, what's interesting here is that you see, this is the total differential equation that you can go and solve, but then you can decide to do simplifications, no?
Mm-hmm.
And all of them will be valid. This will be the assumption. So let's do that, because that one is not really at all the way it is. So now let's say, so let me change the color. So it should be page 4. So using small angles assumption, which I know I already did this figure, but what does that mean? Cosine theta approximately equal to 1 and sine theta equal to theta. So the equation of motion will become what? So let's say it will be m plus m x double dot plus kx plus ml over 2 theta double dot minus theta dot square theta. Equal to 0. Then let's say some simplification. If it was assume that system is initially at rest, what does that mean? That the velocities are 0, no? For translation and rotation. So in that case, it would mean what?
Theta dot equals 0.
0. Okay, and then we have that equation here that will become m plus capital M x double dot plus kx plus ml over 2 theta double dot equal to 0. Okay, so over here, let's do one more thing. So let's say we're going to write this as or x double dot plus k divided by letter m plus capital M x plus ml over 2 divided by letter m plus capital M theta double dot equal to 0, or x double dot plus omega n square x. Oops, that should maybe, alright, doesn't matter. Yeah, maybe let me write this for a second. So it should be equal to x double dot plus theta double dot ml divided by 2 m plus m plus omega n squared x equal to 0, where omega n will be what? K n plus m squared. Okay, guys, so here we went through the derivation, we did those assumptions, because I think it's easier when you do assumption to at the end understand the equation. So what is the meaning of that equation over here? Okay, so let's put the figure we had at the beginning of the problem, which is this one over here, okay? So when you think about it, we have the equation of the block of mass capital M. So what is the meaning of the first term? Maybe look at this one. Maybe this one will help you more, okay? Look at this one here, this equation here, and this one at the end. So what is the first one? What is the meaning of the first term?
Means that the acceleration is functionally accelerating both masses?
Correct, because basically this would be like the big block M will have the mass M plus little m, no? Yeah? To move in translation. So that's the meaning of that one. What is the meaning of, let's say, the last term over here? The theta double dot times whatever coefficient, ML divided by 2 of M plus M.
Would that be that it's essentially a forced oscillation based on the swinging of the pendulum?
So basically that it means that the acceleration of the block, as the block is moving and the bar is moving, the bar is also going to contribute to the acceleration of the block, no? Mm-hmm. Okay? So that's the meaning of that term. That is the contribution of the rotation of the oscillation of the bar to the acceleration. Okay? This is over here. And now what would be this term over here? I mean, I think that gives you the answer. What is this one? What is omega n squared?
It's the square.
That would be the frequency at which this block would be oscillating in that direction. Okay? So the first term is the linear acceleration of this, just the combined weight m plus m. Then the contribution to the acceleration due to the rotation of the bar. Okay? And the last term is the what would be the natural oscillation of this block as it's doing this. Alright, so that's why I did the simplification. Okay, so now if we wanted to find the equation of motion of the bar over here, what do we need to do? We need to use what equation?
Was it equation 4?
We need to use basically equation 4, and we substitute bx. So this is equation 4 over here. We substitute the dx and the dy into that equation, all right, and we just rewrite it. Okay? So let's say substituting, well, what is it? Substituting, we find out what will be the equation. All right, so this would be 1, 2, 3. So the next one should be five. So substituting I and double I into, what was it, 4?
Yes.
Into 4. So what is equation 4? Is the moment equation. So basically this equation here. But that became what for us? Was dx L over 2 cosine theta plus dy L over 2 sine theta equals to I C theta double dot. Okay, so let's substitute over here. What was bx? So, all right, so we have, I guess we can write this as n L over 2 cosine theta. I can already multiply here. Okay, so I have and multiply what's on front, the m of the dx, and then we're over here, which would be the minus x double dot minus L over 2 cosine theta theta double dot plus theta dot square L over 2 sine theta plus minus ml over 2. Oops. I should put here sine theta times g plus L over 2 sine theta theta double dot plus theta dot square L over 2 cosine
Yeah.
and all these should be equal to IC parallel. Okay, so over here it's hard to see, but you can see that this term over here becomes theta dot square L over 2 sine theta cosine theta, and this one is basically the same thing. Omega dot square L over 2 cosine theta sine theta, so these two terms cancel each other. So that's what we have at the end left. So I'm getting a bit lost now with all this. So let's look at this one will be minus ml over 2 cosine theta x double dot. Is that the only one for x double dot, no?
Yep.
Okay. Now let's look what happened with the theta double dot. So we'll have 2 over here. So this would be what? M L squared over 4?
Yes. Cosine squared.
Should I put minus or plus?
Should be minus.
Minus M L squared over 4. And this will give you what? Cosine squared theta. And now let's look at this one. We have minus M L squared over 4. This will simplify. Sine squared theta. And what is this?
All that equals 1.
Oh, that should equal to 1. So what do we have left? So we took care of
There should be a theta
these
double dot
terms,
multiplied to that term.
this term, only this one, no?
Professor, I think, shouldn't there be a theta double dot multiplied to that term?
This one?
No, on the bottom line, negative ml squared over 4 of that term. No, the bottom line, that one. Yeah. Shouldn't there be a theta double dot multiplied in that?
Yeah. Yeah, that's what we're doing, sorry. Yeah. Theta double dot. And then the last term should be, and this one, minus m L over 2 sine theta g equal to IC theta double dot. Okay, so let me just rewrite this stuff over here. We have minus ML over 2 cosine theta x double dot minus ML squared over 4 theta double dot minus ML over 2. So let me put this one over here. Sine theta g equal to IC theta double dot. Okay, and this should be what? The equation of motion of the bar. Alright, so we're going to do the simplifications, and now starting a bit fast, so small angles, which basically will mean cosine theta to 1, sine theta to theta, plus initially a rest, basically means P equals 0, omega equals 0. So this will give us what? Minus ML over 2 x double dot minus ML squared over 4 theta double dot minus ML over 2g theta equal to, I mean, we could put everything in function of what is I sub c?
112 ml squared.
112 ml squared theta double dot. So let me just put it here. We're going to say that I sub c equal L squared of 12. Okay, so now what I will do is that I will say, I'm going to run out of space, but dividing by what?
ml.
ml over 2.
Or ml over 4.
I mean, you can do either one, but but I mean, what I'm saying is that personally I will divide this one because this one is more in function of the theta double dot, no? So personally I think I will try to divide, yeah, I mean, you can, I was going to try to combine these two. Yeah, I mean, whatever you wanted to combine. Let's not just, these two combines, this one correct here?
Mm-hmm.
Yeah, you can add them.
Okay, so let's add them together. So forget about dividing. So let's just rewrite this. So basically we have at the end here minus m over 2x double dot minus ml squared over 4 plus ml squared, oh this is funny here, ml squared over 12 theta double dot minus ml over 2g theta equal to 0. I mean, look, I mean, I know it's going to be hard for you to see this, but what is really this term over here?
squared over 3.
Okay. And what is ml squared over 3?
Moment of inertia of the bar about the pin.
About the pin. So actually it means that probably we could have solved this problem by not using the equations of summation of forces on the ACX or ACY for the bar, no? We can just say is equal to what? Yeah, it makes sense because really that bar is doing what? It's just moving in translation with the mass m, no? And then it's just rotating, no?
Yeah.
So, but basically I want to see this is really I sub b, no? About the point, about the end of the bar. Okay? So if you want, this will give right here. I mean, let's not simplify more, okay, let's leave it as it is. M L over 2 x dot the dot minus I sub b theta dot the dot minus ML over 2G center. Okay, yeah, I'm going to do a division. Oh, what did I put? I sub b. Don't put I sub b here, sorry. Put ML squared over 3. So now what I'm going to do, dividing by what? I'm going to divide here by m L squared over 3. So what will you get?
So you get
Minus
minus 3 over 2L x double dot. I think the L should be in the denominator.
yeah. So what this going to do here, x dot the dot
Minus theta double dot.
minus theta dot the dot. This is really the term that I'm interested in now. Minus, let's say, this should give you what? The m would cancel out.
It'll be 3G over 2L.
3g over 2l
Theta.
theta equal to 0. Or you can write this as minus 3 over 2l x dot the dot minus theta dot the dot minus omega theta squared theta equal to 0, where omega theta squared will be equal to what? Square root of 3g over 12. And maybe I'm going to put myself into a situation, but this value here, 3g of the 12, should be exactly the same value that we got just for the bar. You get this stuff from the problems we solved, remember last time? What was the natural frequency of the bar just working about 1 point? Wasn't it 3g over 12? You should have it on the plasmas. So you see it's exactly the same. So what are the meaning of this? So this is the equation of motion. Of bar. So what is the meaning of this term? This will be the change of angle, no? And this is the natural frequency at which the bar will be oscillating. And what should be this one?
The influence of the moving block on the bar's motion?
The influence of the translational block on the bar, no? So this will be the bar is rotating, is oscillating this way, but also will be moving in translation, no? Okay. So that's the translation. That's the angular acceleration. This will be the natural frequency at which this will oscillate about point B. And that's it. So you see that it's hard to see all the mean of each one of the terms if you don't do simplifications. But once you do the simplifications, at the end, the equation of motion should have meaning, no? You are trying to model something physical. Okay?
Yes, sir.
So I think that's it for the homework, no? But what was the other problem we're doing?
The pulley problem?
That's the one I completely made up. Do you get an answer with the ends or? I think it's pretty simple. I mean, I don't know.
And not an oscillation, but an answer.
So let's look at the second problem. So let me organize my pages, 6, 5. 3, 2, 1. Alright, so it's here. 7. So what's the other problem we had? Let me look at the problem. Alright, so I know somebody mailed it to me, but I have no idea what it is.
I know it's not the best diagram, but
So let's see the other problem. What time is it now?
12:30. 12:30.
And we have class until?
1, I believe.
1, okay. So this problem looks like it is, okay, so it's a disk over here. Which will be connected to a disk over here. This disk and now this is a block over here, and looks like I gave you, this is point A, this is point B, will be your point C. Looks like I give you MA, I sub A. I don't think you need MB, but let's say you have it. And MC. Determine the equation of motion of the block and the pulley, I'm guessing I'm asking.
Yes.
All right. All right, so okay, what I need to decide here is that what is the origin of the current system we want to use? We want to use the one of the block here?
Sure.
All right. So I know it's going to be in that direction, but let's just say this will be, let me call this X, okay? You can call it Y, but. So now this will be moving here. X sub A, this will be X sub C. All right, so how many rigid bodies do we have over here?
3.
3. So let's do the 3 body diagram. So let's see. First one we're going to have over here. Pulley A. What will be the other one? Pulley D. And block. All right, so what should be the forces on pulley A?
The 2 tensions of the string on either side.
Okay, are those tensions equal or different?
Probably different.
Why probably?
Because one's only attached to the wall and the other one's looped through another pulley and down onto a weight.
Okay, but the simple answer to that is that is this system moving or is it in static equilibrium?
It's moving.
So if it's moving, it means they have to be different, because if they were the same, what would that mean? System would be in equilibrium, no?
Yeah.
All right. So this will be this. What type of motion is pulley A having?
General planar, both translation and rotation.
So translation plus rotation. So that means what? This is going to have what? M sub A, X sub A, dot dot, no?
Mhm.
To move in translation. And it will have some I sub A, So here we need to be careful. Let's call this one theta sub A double dot, no? Or alpha. Yeah? Start going a bit faster. So what would be now, am I missing anything? No. What would be the motion of pulley B?
Pure rotation.
Pure rotation. So you want here, I'm going to start it. So the I sub P, theta double dot, B. Okay? Now what would be here the forces?
Weight, the reaction force of the pin, and then the tension on either side.
That's fine, but do you really need them? We'll be taking
Nope.
the moments about which point?
That'd be.
B, so all those forces will cancel out, no?
Aye.
You see here that I left the support. So if you leave the support, then those forces stay internal, no? They don't become external. So you don't need to put them on the figure. And then here what will you have? T3. I mean, you can do it up if you want. Huh? I don't know why I did it that way. You want to do it this way? Since I did it this way, I did it this way. So now what should it be over here? T3 over here. M sub CG. And then this one would be MC AC. Oops, sorry. MC X double dot C. All right? Okay, so now we write down the equation of motion for each one of them. So, so for the pulley A, pulley A, it has translation and rotation. We're going to have summation of forces equals to MA. We need to use the equation in which direction? Only on the X direction, no? Or whatever, on the XC direction or XA direction, whatever you want. X direction, up. So what would be that equation?
Would be
T1
plus T2 minus MAG.
minus AG equals to
MAX double, or XA double dot.
A double dot A. That would be the equation. One. But what type of motion is also that pulley having?
Rotation, so you have to do some of the
So let's see if I can do it from here. Summation of moments about which point?
Point A.
Point A. So what would be that equation?
You can do minus T1 RA.
So it will be, let's see, yeah. So can I just say T2 minus T1 to save some space? RA, no? For the moment. Anything else? That's it, no?
Yep.
Equal to I sub A omega double dot A. Equation 2. I mean, guys, you see that it's always the same procedure, no? Can I go to the next page?
Yep.
So 8. Now we go to pulley B. What type of motion is pulley B having?
Pure rotation.
So what should be the equation we should be using?
Sum of the moments about B is equal to IB theta double dot B.
And this time, what would be the equation?
The T2 minus T1 all times RB.
Wait, T2 gives a positive moment, no?
Yeah, T2. Yeah.
Minus T3.
Yeah, T3, sorry.
So it's T3 minus T2.
No, it'd be T2 minus T3 because T2 should be giving me positive moments going that way. Isn't it?
Yeah, so it's T2 minus T3. T2, yeah, minus T3 R sub B. So let me add then here on this figure here the R sub B. Anything else we have on that one? That's it, no?
Nope, that's it.
Equal I sub B beta dot B. Equation 3. Okay, and now we have the block. So what is the equation of the block? Summation of forces equals to MA. So what will be the equation over here?
T3 minus M sub C G is equal to M X sub C double dot.
X sub C, no?
Yep.
Okay. Next, what we need to do?
Determine how many equations and how many unknowns we have.
Okay, so how many equations we have? 4. How many unknowns we have? T1, T2, T3.
XC, theta B, and theta, or
Yeah, X double A, X double dot A, X double dot B, theta double dot A, theta double dot B, no? Okay? So where are we going to go find additional equations?
kinematics.
Kinematics. So this is the part that can be a little bit long. Oh, okay. Alright, let's see if I can finish this part. So I'm going to start going a little bit faster, so let me just redo the figure here very quick. Alright, so this will be point A over here. This point B. This point C. X of C. X of A. Okay, so here is going to be a good review of dynamics. So let's see, what is the velocity? Okay, and here I made one assumption. Okay, in this part I make one assumption in everything is initially at rest. Okay, we'll go a little bit faster. So initially at rest. Okay, so what is the velocity at this point?
Which point?
Here, where the bar, where the bar is attached to the wall. What's the velocity over here?
0.
0. So what should be the velocity over here?
Also 0.
0. So let's say let's call this point P. Vp is 0. If you remember, this is what is called an is the antenna center. Okay, so it would be point B. sorry, point A in the middle of pulley A. Let's call this point here Q. This point over here must have the same velocity as that point over here. And then this point over here should have the same acceleration as this point over here, no?
Mhm.
So we could say this also point C. Any question?
No, sir.
Alright, so now I'm going to start a little bit faster. So I need to find relations between the omegas and the acceleration. So I'm going to find the acceleration of point C. Alright, I'm going to find first the acceleration of point Q from point P. I'm going to find the acceleration of point Q from point B. Okay?
Okay.
I'm going to equate those two relations, and they should give me the relation between omega sub A and omega sub B. Okay? So let's do that. So acceleration of Q from point P. So initially, it's at rest. So what happened to those two terms?
They both become 0.
What would happen if omega wasn't 0?
The A at point B would still be 0, I believe.
This term will cancel this one.
Ah, okay.
Alright, here I got 0 because omega is 0. Alright. So we have acceleration of Q equal to IJK 0, 0. Let me just talk with the alphas. Now it's going to go a bit faster than the dots. Alpha sub A. What is the position of Q with respect to P?
2R I hat.
2R sub A, 0, 0. So that means that A of Q will be equal to what? 0, no, sorry. Yeah, 0, 2RA, alpha A. Okay? And we'll do the same thing for the other AQ. So you want for this one, letter A. And now the one will be what? The acceleration of Q from which point? B. So this one, yeah, this is 0. This is 0. Leave our space over here. Alpha sub B. What is the position of Q with respect to B? Minus RB 0, 0. So A of Q will be equal to 0 minus RB alpha B. Okay, I'm going to be faster because I want to finish. Hopefully we can finish. So now I'm going to equate those two in relation because they represent the same point. What do we have? Acceleration of Q equal to 2 R sub A alpha A equal to minus RP alpha B. Or if I just look at this section, 2 R sub A theta W dot A equal minus R sub B theta W dot B. Okay? So I don't know, you can choose either one to be the equation here. Equation 5. We probably need to solve for one or the other, but I don't know. What is the equation for the block? Oh. Okay, or rewrite this one, or I don't know, which one you want to write in function of the other one. Let's say that sub B will be equal to minus 2RA over RB theta W dot A. Okay? Okay, now I think we kind of discussed this last time. How can we find a relation between x sub c and x sub a?
Should be that x sub c is negative twice of x sub a.
Yes, but why? I mean, it's easy to understand, but then we need to prove it. Because what happened when, let's say, if this one is moving a distance 1, correct?
Yep.
That means that what?
That rope is moving the same distance.
That rope is moving the same distance, but here you have the distance on both sides, no? So each one of the sides is going to have to move half, correct? But it's going to move half on the same amount of time that this one is moving 1, correct? So that means that it's moving half the distance in the same amount of time, means that will be the velocity.
Yes, sir.
It should be slower, no?
Yes.
So how can we say that mathematically?
The x sub c dot equals equals 2 x sub a dot.
But I mean, we need to find okay, so one way we can do this, I think, is we can find the velocity of point C from point B. You have that figure in front of you? We'll find the velocity of point C from point B. Then we're going to find the velocity of this point, which will be the same as this one. And we can calculate the velocity of this point from point A from here, no? Okay. And then we can see what is the relation. So dc plus
omega v cross r c from b.
Yeah. Plus omega b cross r of c with respect to b. Okay, so this will give us what? Zero omega b. Position of c with respect to b will be answer b 0. So I'll start going a bit faster here. It will give you Vc equal to Rp omega. Then we find the velocity of point Q from point B. R of Q with respect to B. What should that be?
The same but negative.
Same as negative. So let's go a little faster. So we'll be minus R sub B omega B. And now we can find the velocity of point A from point Q. So this will give us dx 0, 0 omega sub A, and what would be the position of A with respect to Q?
Minus RA. 0, 0.
So this will give us now that the A equal to minus RB omega sub B minus R sub A omega sub B. Okay, so I know here I'm going maybe a bit too fast, so you have this one here. This one here. But now from equation 5, I mean, I don't know if it's that clear, but what do we know? Theta dot sub B equal to minus 2RA R sub B theta double dot A, or this will mean what? Theta dot B, which is omega B, no? Would be equal to minus 2R sub A R sub B omega dot A, and you know that omegas equal theta dot. So if we substitute these relations into this one, so let me say one thing here. This would be BC equal R sub B theta dot B. Okay, so that will give us what? VA equal to minus RB times what? Minus 2RA over R sub B theta dot A minus R sub A theta dot A. So this will give us VA will be equal to what?
RA theta dot A. You simplify it all the way.
Right, so that we already did that. So we want to have it in function of theta B. So maybe I should do the other transformation. So sorry for that. Let me erase this page. We forgot about it. So page 10. We do the same thing. So VA equal to minus R sub B theta dot B minus R sub A. Sorry for that. So we need to change this one to the other one. You see see, so this one should become what? Theta dot A is going to be equal to,
Negative 1/2 R sub B over R sub A.
so
theta dot
negative
B.
R sub B over 2 R sub A, no?
Mhm.
Times theta dot B. And now, after simplification, we should get that dA is equal to what?
Minus 1/2 R sub
Should be minus 1/2, but that is R sub A. This one, so this should have, yeah, minus R sub B, theta dot B
over 2.
over 2, which is DC, no? We're over here, no?
Negative
This is, so this is where, what is this term over here? Where R sub B, theta dot B is equal to what?
BC.
DC, so it will be
Negative 1/2 BC.
negative 1/2 DC, no? So from the expression, or you can say that x sub A will be equal to minus 1/2 of x sub C. I think it's time, no? I didn't finish, but okay, guys. So basically, I think you can finish the last step on yours. So now, what do you need to do? We go back. Let's say if you want to write down the equation of 2dA, okay, what do you need to do? So probably you need to solve the equations for T1, T2, no?
Mm-hmm.
And then you will substitute. So if you write everything function of XC, you need to write XA is equal to what? Minus XC over 2. And you find one relation. If you want, we can finish it next time. Okay? But, I mean, any question about the procedure over here? I mean, it can be long and tedious, but it's always the same thing, no? All right, so let's do something. Let's build on the homework. So now what I'm asking you is to finish this problem, okay? And do the problem, the first problem we did in class today, using NG methods. Okay?
Yes.
Which is the Lagrange equation, or Legendre equation. All right, so I'm going to stop this.